All right. Oh, right. We wanted to remove this. I believe it's this one.
I didn't have enough space to fit the words eating for
What? Let's see if this works this time. Okay. And this entire thing. So, excuse me. Wow. There we go. Let's see if it works. Oh, interesting. That's not what I was expecting. It does work. It just doesn't work the way I wanted it to. They are back. I'm kind of curious as to what we're gonna see here. Oh my god, yes. Look at all the rag dolls. It's fantastic. Can I pick them up? Yeah, I can. It's it feels sluggish and slow to get them started. So there's 20 batches. I don't know if this demo required this to be ragdoll. Like, uh, entity component system. I feel like this could have been done without entities. Anyways, it from what I was looking at, it looks like the ragdoll system is going to be pretty easy to get going in here, so I'm pretty happy about that. Doo-doo-doo. Hover prefab. Oh, that's their their hand pickup thingy. Physics step. What is physics step? Unific physics occurs in the following order. Since the simulation is stateless, i.e. does not cache anything frame to frame, it must get the current state from the component on the body entity. The simulation then, at a high level, takes all active bodies in the scene and checks to see what shapes are overlapping. This is called the forward phase. Broad phase? For any shape that overlap. Any shapes that overlap, if they should collide based on their filter information, the exact point of contact is calculated. This is called narrow phase. Based on those collisions, a response can be worked out that takes into account the following parameters: mass properly, such as weight and inertia, friction, restoration, bounciness, point of collision. Ugh. Freaking stuffy as all hell today. All dynamic bodies are integrated forward in time. This is done by moving the dynamic bodies according to the linear and angular velocity, while taking the current time step into account. Finally, the new transform for the body is applied to the entity that represents that body. Oh, look. Yay. Okay. Moving on to the most important part, which is this. Let's get this working. So we only want to apply an upward force when we are on the ground. So to do that, this is the wrong project. Vehicle machine authoring. It is chilly as fuck today in this room. Like it's actually cold. I don't know what temperature, but it's cold. I could plug in and find it. But I'm gonna be a bit lazy on that one and not bother. Okay, so what do we got? Actually, it just doesn't display anything. But it's also dead. Okay, so what we want to do is only apply this impulse if we actually have a collision. So now we need that ray cast. And this is kind of where we're going to do the raycast vehicle. Scripts. That's not the raycast. World.raycast. That's the raycast. Nope. Physics world. Raycast. And then the raycast input is a pre-built raycast that we have to do, right? Raycast input. Wait. What? Interesting. Oh yeah, this will allow us to actually have like um things like this layer here needs to be ground. So let's figure out how we're gonna do that. Layer drivable. I want to change that actually. Actually, no. We'll say we'll just say drivable. Okay. Wait, how do we get back to how do we get back now to my regular inspector? I need a new inspector. I need a new inspector. No. Wait. It's right click, add tab, inspect. Oh. hmm Let's add one more inspector. Can I rename these inspectors? Anyways, this is supposed to be ground or drivable. So what we're looking for is the drivable one. Returns true if the filter cannot collide with anything. Oh, right. I wanted to add another one that was going to be vehicle. Player. So that's layer 6, layer 8, and this is a 32-bit int, so we can work with that. So what we want is belongs to, what was it? It was 6? 6. Collides with 5. Group index 0. That's fine. Free Payo is a player. So I wanted to ignore um, I wanted to ignore everything except for the I wanted to ignore everything except for the ground. Specifically, I wanted to ignore itself, which is fine because that can just be itself. Turns true if filter cannot collide with anything, which is likely means the default construction. Ah, I think this is kind of what we want here. Okay. Let's see the raycast. What we want is we want to start with the front. Which direction are we facing? The front left. Yeah, front left. local up times um, do we have any of the wheel data? We don't have any wheel data, do we? 10 out of 10. Dot max length. To start though, we want plus the up vector times max length, and then this is the minus. And this will give us a start location that is the very top to the very bottom. And then I want to draw a debug line. Debug.drawArray. Draw line. Raycast input dot start. Raycast input dot end. Is it missing the color? Oh, yeah. No, that wasn't it. I think it's in this one. Oh, that's Gizmo. Is drawLine actually the one that takes it? Okay, yeah. There we go. Come on, give me a color. Oh, there we go. We got our color. Our color is wrong, but our line is in the wrong spot, but we've got a line. What we're gonna do is say don't render these because right now they are going to be a bit too distracting. You know what? That is in the center. So we're good. We're good. We're good. But we don't we now we don't have the wheel length. Is it plus the radius or minus the radius or multiply by the radius? I feel like it's plus. Wait, there we go. Yeah, there we go. Okay. So what we're gonna do is we're gonna color it red if it hits, and green if it hits, and red if it doesn't. If hit, Hmm, there, and then this is the race start. It's not hitting. I bet it's my filter. Raycast, Ray, Unity, Raycast, input. The collision filter is used to determine what objects the ray is and isn't going to hit. I think project settings. Settings here. Player hits everything. Drivable hits everything. So if everything is hit by it, then why are we not getting anything? Oh wait. Player does not hit player. That's probably what it is. Nope. Fuck, why can't the space heaters in here just work better? When I say space heaters, I mean my computers. Okay, so let's go back to here. And what we're gonna do is we're just gonna do YouTube.
When the player pushes some of these spheres, you can see they are also moving and they will fall down. Next thing that we will be working on are the raycasts. So I will make a trigger that will be just detecting if the balls fell from the ground. So again, we'll need to create 3 new scripts. One will be the trigger component, second one the trigger authoring, and third one the trigger system. The trigger component is just holding a size. For now, we'll be working just with sphere casts, but you can use it with any other cast you want. And the trigger authoring is again the same thing. The thing that I will show you how to do is work with layers, so that we can check for the collisions just on some specific layer. So I will select the player, and I will set it to the player layer that I have created, and I will also select all of these spheres and set them to the collectible layer. Back in the trigger system, when we are working with the spherecastAll function, you can see the last parameter is the collision filter. So we can just create new one, and we can specify 3 parameters, but we only care about the belongs to and the collides with. So the belongs to in this case can be, for example, some trigger layer, the player layer, and so on. And the collides with layer will be the collectibles layer, because we want to be able to pick up the collectibles. But right now you may not be sure to which value you should set all of these variables, so I will just create enum that will be holding them. So in the collision layer enum, I'm just specifying all of the layers and their values. The way that I'm setting these values may seem a bit weird to you, so you may want to check my tutorial about bitwise operators. But what this is essentially doing is it is working on the bit level, and it is taking a 1 and sticking it 6 places to the left, so the final byte looks like that. Now, why did I set these layers to these values? Well, when we take a look back into Unity, we can see that the player layer is on the index of 6, and the collectibles layer is on the index of 7, which is the same number that I set it to in this enum. And now we can apply these values to the collision filter, so I will set the belongs to the player layer, and the collides with to the collectible layer. So it should look just like that. And all of the layer indexes have to be unsigned integers. And if you don't want to be creating the enum, you can just specify the value right when creating the collision filter. Back in Unity, I made the trigger really big, and because all of these collectible objects are set on the collectibles layer,
I did change the colors, right? This should be. Can we do a draw debug? I wish debug draw had more options. Because Gizmo doesn't. Like, wait, draw ray. How's a ray? It's like, I want this, but I don't think gizmos work. Center, and then the radius. So we'll say the center is the position, right? So it'll be ray cast input, or sorry, ray result dot position, and this would be the radius. Let's say 0.5 f, and then we do the gizmo color, gizmos dot color. And then this would be a color, temp color. Equals And we'll do the same here. I don't think this is going to work, but we're going to find out. But yeah, I imagine this isn't going to work. That's what I thought. Gizmos is even turned on, but we still don't see them. Because gizmos don't work there. I hit nothing. Look at that, it still hit nothing. Do I need a group index?
We should be able to just throw it. And all of the layer indexes, I made the model physics-based gameplay player so that this video it works. Now, so it should look just like that. And all of the layer indexes have to be
Excuse me. Still, I hit nothing the entire way down. Just absolutely nothing. We had this working at one point. Collides with 5. Okay, let's double check what 5 is. 5 is UI. 6 and 7 is what we want. Belongs to 7. Collides with 6. Can't imagine why it wasn't working. There we go. It worked. It worked. Okay. There we go. We got it working. Okay. So now we take the hit position. We do a little bit of upward math on it, which involves the velocity of the vehicle coming down. And then that will be our velocity going up.
Set and our velocity, but then we plug those
Our rigid body. Get the velocity of the from physics velocity. There's our linear velocity. Now we have everything. We have literally everything. Oh, wait. No, that's not it. So we do the physics velocity dot. Is it this? Or is it world? Velocity value read o dot get point velocity. Oh, maybe it's world then. World dot sorry, physics world dot get point velocity. To unity get point velocity. The velocity of the rigid body at the point, world point, in global space. Okay. Get linear velocity. I feel like it's this. Yeah, so this is probably body position, body orientation point. Wait, I have a feeling this is probably world space velocity of the tire. World space velocity of the tire, but the tire doesn't have a get point velocity. Rigid body, get point velocity. Unity dots get point velocity. So velocity of point offset from center of rigid body. One sec, let's quickly clean this up a little bit. There's a bunch of these we can just close.
Good game feels.
Compression ratio between 0 and 1.
This guy actually has released this as packages, which is kind of crazy. It is so cheap, apparently. Holy shit, $250. He even has the AI for it. The problem is that it's not actually physics. It's not actually dots compatible, so I can't use it. But this is actually the vehicle system that he's imparting. He's going over here. But what we want is to figure out how we get the point velocity. So I think we can do that through here. There's the raycast. And if we come down, and a wheel rotation. We'll come back to that. Suspension? Impulse. I want to say that's to get linear velocity. Oh. I don't think this is going to work. Because we've not had luck with physics world dot get linear velocity, and then we pass in the rigid body index, which we never seem to be able to work with. Get rigid body index. Yeah. I don't think this is going to return the correct thing, so I'm not going to hold out for it. Oh, ray result dot rigid body index. Ah. And then this one's a position, which is position B, which is the ray result position. Position. I think this is going to cause a problem if we do it this way, because this could be it could be velocity at wheel. Ooh, one sec. It's
About things like our
from tire transform position. World space velocity of the tire. Calculate. One sec. Get linear velocity. And then velocity at wheel. I think that's what we want. Velocity at wheel. The wheel position. CE position minus wheel position equals CE position minus. Okay, so the wheel position. The wheel position would be the ray position, right? The ray position minus minus times the wheel radius. Mm. And this returns a float 3. Okay, so we do float 3. Wheel. Or sorry, velocity at wheel. At wheel. Then we can do this in here. And then we can do this in here. And both of these can be velocity at wheel equals Then this, instead of ray position, we just do wheel data. We have to. We have to. Wait. If it didn't hit them, then it's at the max, right? So it's at the ray endpoint. Ray cast input dot end. There we go. There we go. And then we're going to get rid of the other debug because we don't care about these. Just so they don't muck up the readings. That's all. I just care about the velocity of the wheel right now. There we go. Beautiful. Okay, so now what we're going to do is we're going to do an upward vector based off of the... Oops. We're going to do the upward vector based off of this information here. Direction tire transform. Okay, so I'm gonna apply extra force because I don't. Right, we're just gonna do this for now. Spring direction. This is a float. Float 3. There we go. So we have our wheel direction, our wheel velocity, whatever. Then we want the float offset equals suspension. I'm just gonna write it out. Suspension rest dist minus tire ray. Tire ray dot dist. So, okay, one sec. Let me bring this all down here. I feel like this is actually what we should be using. But like, if ray did hit. Okay, this is if ray did hit. Okay. So this needs to all be up in here. Which actually makes perfect sense. Okay, so if ray did hit, right, we want the world space direction of the spring force. Then world space velocity of the tire.
offset and our velocity, but then we plug those in.
Then we want the late offset from the raycast. Interesting. Late velocity along the spring direction. So this returns the magnitude of the entire world cell velocity in spring direction. As the projected spring direction. This has been recommended to me for no reason, so I'm giving this shit a like and a subscribing. Interesting. Are you a developer, Boop Boop? Velocity as a. Wait, where was I? The spring direction. Onto the spring direction. Also, thank you for the like and subscribe. It's much appreciated. I think the YouTube fireworks didn't go off. Float cell equals vector 3 dot spring direction and entire world velocity. No background. I'm literally watching frogs and brain rot, and somehow this has been on my recommendations. That's weird. YouTube has the weirdest fucking recommendations sometimes. Wait, I did this wrong. This is supposed to be the tire velocity, but the tire velocity is being calculated up here, which is wrong. And this is supposed to be this one, and this one's supposed to be this one. And then we do the apply the force at the location of this tire in the direction of the suspension. Do you play a lot of video games? Or watch a lot of video game based content? It's the only other thing that I can think of. As to why you'd be forced into the hellhole that is my live streams. So because you just got here, I'm currently in the midst of porting my game from Unreal Engine over to Unity. The game is a truck driving game where you drive around Tokyo and you run people over. They ragdoll and fly all over the place. Show you the current state of the Unreal game because it's much further along. Because I just started porting the Unity game. And with the Unity game, I have to build the entire vehicle system and the ragdoll system, and well, not the ragdoll system, but I have to build the vehicle system and all the AI systems and stuff like that from the ground up. And a lot of that came with Unreal, so. But stuff in Blender since I just do random shit for Roblox because, you know, I'm stupid. And one sec. Let me move my cursor real quick here. And can't play fair. Oh, that is fire. What the fuck? Wait, I'm so confused. So this is my current game. How do you find Lua? I think I've tried Lua. I tried Lua once or twice for modding video games. I've seen some Roblox based stuff. Yeah, there's currently a couple bugs here where the capsules that dictate the girls' positions don't reset properly, and it's causing me headaches now. It wasn't always like that. There's versions of the game where it's not a problem. Yeah, I had a feeling. It seems like it's fairly simple to get into. It is specifically developed with that in mind. So this is my game at the moment. You kind of just drive around and run people over. In the future, I want to have these look better, right? And I want to have vehicles on the road and stuff like that. And I was getting into, when I started putting vehicles on the road is when these girls broke and started doing weird things. And the reason for that is that the entire system that I'm using in Unreal to power the girls walking around is experimental. And because of that, there's problems. And in Unity, the Unity version of it is not experimental, and that's why I'm looking at a port to Unity. Here's the world map. This is the actual city map that I'm working out. I'm going to be replacing like every building in this city with something lower res because they're a bit too big and clunky to work with. But it will eventually load. You can't see the loading screen that I have going because it's yeah. Not gonna lie, that makes sense. Yeah. I played with the only Lua I've done, like I said, was the World of Warcraft plugins Lua. And it was interesting. It wasn't too bad. Yeah. But yeah, so the tire velocity does not exist in the current context. What do you mean it doesn't exist in the current context? Of course it does. You're full of cheese and lies. Lua is way bigger than Lua. Lualu? Lualu is the subset of Lua that Roblox uses, or is it actually like an actual different language? I legitimately don't actually know. I've kind of like I've watched some videos where some people talk about like their Roblox projects, but I've never actually played Roblox. Oh, here we go. So this is the city as it is right now, and I'm gonna be slowly replacing every building. It's based on 5.1. Is that an old version or a new version? So the newer buildings are like this one here, and our older buildings are the old buildings are everything else that's not colored. And not all of the new buildings are textured, so they're it's a slow process. Or have collisions. Not all of them. Is Lua and Lualu the only two languages that you know, or older? Do you program in any other languages, or is it just those two? Waha! Oh man, she got stuck. Let's go back. Oh, she disappeared. I can also like F8 and fly around the city. Yeah, so like there's one building, another building. This is one of the hero buildings. It's a very important building, the 109 Shibuya Station building. Really important. Got some of the artwork done by a couple of my streamer friends. That one and these two. Oh, and this one over here too. And then our placeholder anime girl that's not in the Unity version. And the doggo. Good doggo. I'm in college right now. I'm starting to learn Python and stuff. Oh, Python's a good language. I like Python. Python is my primary language right now. Although, who knows? It might be something different soon. Actually, technically, I guess C# is my primary language at the moment. But I've been doing C# for all of like 2 weeks. I think we can go back and we can find the exact date that I started learning C#. Let's see. You turn into something out of a scary movie. That's fair. I can show you what the the quality of character that we're going to be getting. One of my friends is going to be making them. Let's see here. Not Twitch. It's actually I think I can get to it by Twitch. Go to his Twitter. It wants me to sign in. Whatever. Give me a moment. More options. I can allow. One of my friends is doing the all right, one of my friends is doing the characters for this. Yeah, so here's some of his stuff that he did recently. They did this. I unfortunately have to go since it's like 2 a.m. and I have Saturday class. I'll catch one of your streams again when I see one. Sounds good. Have a good one. Thanks for stopping by. This is what things are going to look like eventually. Okay. Let's get back to trying to figure this out here. Oh yeah, tire velocity. All of this is broken because of this. So we have the information now. Now we just need to make sure that we actually allocate this all correctly. So suspension rest distance. Do we have a rest distance? And if not, we're going to have to make one. Yeah, we do, rest length. Which is, I think rest length is max length times 0.5. Give me 1 second here. I'm just going to make sure that I actually fix that. Rest length is max length times 0.5. For anybody who doesn't know, we do 0.5 like that because we want to divide it in half. And this is faster, like substantially faster. Oh yeah, we're going to have some issues here, and then we're going to do the tire ray distance. Calculate the offset from the ray cast. The offset from the ray cast, which is suspension rest distance, which is wheel FL data dot rest length minus the tire ray, which is the ray result dot what is this? Fraction along the that's not it. Collider key, material, entity, position, surface normal. I think we just need to wait. Calculate the offset from the ray cast, which is the offset from where the tire currently is. No, from the ray distance, from the location, the rest location to the I can think. Yeah, okay. So because this just gives us a number between 0 and 1. So we don't actually have access to what they want. Yeah, we don't have access to that, unfortunately. Fuck, that sucks. The end position of the ray, the end position of a ray. Ray dot displacement. That's actually what we want, I think. I think it's ray dot displacement, right? Actually, that might not be true. Anyways, what we want is so we have the rest here. Does this come back with I think this is a world position. Returns the point in query space where the hit occurred. So if we do debug.log ray result dot position. I think this will tell us whether or not we're in world space or not. And I think we're in world space. So we'll need to convert to local space potentially to get the tire distance. Here's our truck. Go back to the inspector here. Okay, so we're at like -5. Where are we normally? Okay, yeah, so that is a world position thing. Okay, so we need to transform our rest position into a world position. But we have a world position for the right. We have the position. So if we do wheel FL data dot rest position minus, and then we do a float 3 offset equals this should do the thing, right? Because these should both be float 3s. What's the issue? Cannot. Oh, wait, right. Position. I'm going to change this here. We're going to go like this, and we're going to just do find usage. And it's being used in a couple spots. So all we're going to do is we're just going to do this, and we're going to do rename. Rest location. Local transform. Rest local transform. Okay, so what's the issue here? This should be returning a float 3. This is a float 3. This is a float 3. We're minusing them. We should get into float 3 for offset. Not resolve float 3. It's probably because I didn't spell it right. There we go. There. And then if we do offset. Let's see what our offset is. Let's see if it sounds valid. That feels valid. Okay. Now what we need is we need to, now that we have the offset, calculate the velocity along the spring direction. So this should be a float, and we should use float 3 dot How does one do a dot notation? Oh my god, that's float 3 dot notation. Or sorry, dot. Relation. To do vector 3 dot. Okay, so the dot product is a float value equal to the magnitude of the two vectors multiplied together and then multiplied by the cosine of the angle between them. For normalized vectors, dot returns 1 or minus 1. What we want is a float 3 dot product. And we want this in Unity. And that's what it is. It's under the map. Okay, so what we do here is we come back into here and we do math dot dot, and then we pass in these two. The spring direction and then the tire velocity, which is velocity at wheel. There. Then we do the calculate the oh, I skipped that. Calculate the magnitude of the dampened spring force. Chrono, welcome back. Okay, so this would be offset times spring strength. There. And then we add it. We add the force. So the spring strength will be wheel FL data dot spring strength dot strength. And then the dampening would be wheel FL data dot dampening. Cannot convert type mathematics float 3 to target float. It's probably the offset. Where's my offset? Yeah, my offset is a... yeah. Okay. Wait, then where do we get the suspension rest distance? And then the tire distance. We need to get the raycast distance. The ray result distance. Ray distance. Ray distance. And then we need the suspension rest distance. Which is do rest length. And this is supposed to be a float. There we go. Then it is this. And then the force here is the spring direction times force. Where did I do force? Where is force? Force magnitude. There we go. Let's see if this works. This should work for exactly one of them, maybe. Let's see if it works. It does not work. We are... I think what the issue here is our strength is not enough. Breast length. Breast length doesn't even matter because we're not actually using it. Sure. Let's do this. We're gonna debug the force magnitude as well. Something's definitely wrong. Let's try the what is our local up? No, our local up is right because we are shooting down and we can verify it. We've verified that we're shooting down, so local up is correct. The length might be wrong. Like these might be backwards. What if we do this minus this? We are on the right wheel, right? Like I'm attacking the right wheel here. Front left. Okay, yeah. This is the right wheel. Okay, we could give this something really crazy, but I don't think I want that. Okay, so what we want is let's do this. We're going to do this equals multiplied by the wheel FL data dot strength. And then minus the wheel dampening there. There's something wrong with our math. Our math says wrong. Here we go. Yeah, so our spring direction, like we're definitely getting like this is definitely giving us a bad value. So if I take this and we do a debug.log, right? And here we say the impulse. This is going to give me a bad value, I think. And then if we do local up, I think we're going to get a bad value. I think it's applying the force downwards, not upwards. Yeah, we're applying it downwards with great gusto. See, this is negative. So it needs to be applying it up. Okay, so velocity at wheel. Ray distance. Actually, we can do all of this together. Let's do this all in one debug so we don't have lots and lots and lots of debugs here. So all we're going to do is this. And then we're going to come to the very beginning here and we're just going to do tab like that. There we go. And we've got the velocity at wheel. Then we want, sure, the offset, but we want the ray distance. No, we've already got the ray distance. Okay. Then we want the vel, which will be velocity. Very cool. Oh, thank you. I'm trying. I barely know what I'm doing right now, so bear with me. Uh, 119. Huh. Interesting. Okay, so it doesn't like me building that string. Or that was no, yeah. Oh, it's just burst compile. We can ignore it because burst compile doesn't matter for this. Okay, there we go. Now we've got all of our data here. What's your game, if I can ask? It is called Isekai Crusader Truck-kun's Realm Rescue. And you drive around Tokyo, running people over to save to send them to other worlds to save them. And the entire concept is truck meets ragdoll physics. So we got a 0 velocity on this the entire time, and oh no, we didn't. We got an actual velocity here. There's a problem right here. Oh wait, what? I don't care about that. That sounds amazing. I'm hoping that it will be. I'm porting from Unreal because Unreal's entity component system, which is required, is a buggy mess. So okay, yeah, all of these are 0. These are all 0. We have no velocity. So at least we figured out the problem. Velocity is 0. I think it was velocity, right? Yeah. So this is 0. The ray distance is 0 on all of these. We have a 0, 0 there, 0 there. The offset is this. The ray distance should be. Wait, why is the ray distance float 3? I feel like that's wrong. Force magnitude. Is negative 183. The up is correct, and the impulse float is going down. Fellow Brave user, yes. For streaming though, I use Edge. Use Brave for my day-to-day. I was trying to use Firefox, but like Firefox on YouTube is just fucking so bad. It's so bad. Well, at least we know why I'm not getting my up. Like, we're not pushing up. It's because we're applying force in a negative direction. Edge is great too. Yeah, Edge isn't too bad. I would love to see more. Like, I'd love to see Firefox not get gutted by like YouTube and stuff, and some of the other Google websites and stuff like that are so prevalently used. This is like the only other browser on the market. There's effectively 2 browsers. There's Chromium and Firefox. And if you're on a Mac, you can use Safari, but why would anybody use Safari? It's freaking garbage. The only thing Safari's good at is debugging mobile apps. They do it on purpose to make people want to go to Chrome. Oh, I'm well aware of why they do it. I think that it shouldn't be allowed. And I think there's an antitrust probably somewhere that's going to come for stuff like that. Actually, there is an antitrust. I think they have to divest from Chrome. Like I think Google is being forced into divesting from Chrome. but it's not. It's being divested into an open source, like a proper open source project. But like all the people committing code to it are still from Google, and the people leading the project are like Google, right? So, yeah. I don't like the mononess of it. So I know what the problem is. It's this. Velocity at wheel doesn't make any sense because we're using the physics body and the rigid body stuff doesn't work anymore. And it could just be like an issue with mine, but like, yeah, it just doesn't work anymore. Downloaded Firefox a while back because I was going to use ArkenFox, but was too lazy to set it up. What is ArkenFox? I've never heard of it. Ah, neat. I use the stripped down version of uBlock Origin. So these are I use so few plugins. I have thought about I've actually thought about this one since I'm doing more Unity development. I've thought about making a plugin for this, and we might actually do that because I'm sick of looking at this white screen. It hurts my eyes. I know that there's I use Dark Reader for that. I don't like using third-party plugins for browsers because they have too much control. Right? So, do you remember does everybody out there remember the honey controversy? Right? The whole honey thing where it was just like, "Oh, it's doing this really creepy weird thing and it's collecting a lot of data." Right? So, I never used honey because so I never signed up and I've never signed up for or used honey for one reason and one reason only. I did not know how they were making their money. And right? So like I didn't know how they were making their money, and it's giving unfeathered access to every single website that I visit to them. Right? They have the ability to inject any code they want effectively into any website I visit. And I was like, that doesn't sit right with me. Right? Like I don't and the rule of thumb is if you are not directly paying for the product, you are the product. Right? So my question was always, how are they making the money? Are they making it through collecting your personal information? And then at that point, they have the ability to collect your passwords, your email addresses, phone numbers, credit card information. There's nothing they can't touch, right? Once in a plugin, you can touch everything. So it's just like, I don't want that because I don't trust them. So no. Yeah, and that's why I never used them. But it was always weird. I was just like, how do they make their money? Because they're not making it off of like there's no way they're making enough money off of people to support the business unless they're doing something shady. And then it turns out like a couple years later they're doing something shady. That's how they were making their money. It's not the way I thought they were doing it, right? Because I thought that they were doing really, really super invasive. And keep in mind, I never publicly talked about it because I was just like, I can't verify any of this because I don't want to go look into it. I don't want to install their plugin. I don't want to sign up for their service, right? So I never looked into it. something felt off about it. So I was just like, I was like, I don't know how they're doing it, but they've got to be doing something shady. As in, like, they've got to be doing really, really crazy high level data collection on everything that you do and selling the shit out of that to people. Or they're doing something even more shady than that, and I don't know what it is, and I don't want to find out. And then a couple of years goes by, and it comes out, oh, what were they doing? They were ripping off affiliate links. And I was just like, oh, okay, so that explains how they're doing it. Yeah. And then like for like Dark Reader and stuff like that, it has a lot of access to your system. So I'm just like, I don't really want it for one website. I tried to limit my add-ons to only Firefox recommended ones, and even then, I'm like, yeah, I limit my add-ons to like the ones that I kind of need to make things work. So I have my LastPass, right? Because I need that to log into things. And I pay for LastPass. So I pay for the product. So I am not the product. They're not selling my information. Yeah, 1Pass is another one. You're paying for them. You're paying for the service, therefore you are not the product. And then uBlock Origin. I feel comfortable with uBlock Origin, specifically the one from Raymond. I think it's Raymond Hill or something like that. I recognize his name when I go and install a plugin. But specifically his one, I feel comfortable with, because he is incredibly hard stanced on that plugin. It is open source, so you can go vet the code. But more importantly than that, he refuses to take money from anybody for the product because he doesn't want to feel obligated to maintain it. And he doesn't want to. He doesn't want that to shift his influence what he does, right? And so he's very principled in that. So I feel pretty confident in that he's not letting things slip through and stuff like that, and he maintains the shit out of that. So I support those two. They're the only two plugins that I use. Yeah. I'm using the light version though, which sucks because I'd like the full version, but you know, Google. But also making a dark mode for one website is not very hard. Yeah. Make it like we could do this really easily. Watch. Sorry. Edge plugin development mode. Is it manage extensions? Yeah, I'm fine with that. Oh, it's super easy. Like here, let's just do it right now. We'll make a plugin to change the change it, right? Turn on developer mode toggle. When installing your extension for the first time, do develop loading starting a Chromium plugin. Yep. Okay, let's let's do this. We'll install the required thing for this, which is CLion, or sorry, WebStorm. I really hate the way that they did that, where they're like free for non-commercial use, and it's just like, bitch, I pay for this. Yeah, it's super easy. So all we're gonna do is we're gonna go and take a look at like what the individual things are on their website, and then we're going to override them, right? So as soon as it finishes installing, which it should be almost done. There we go. WebStorm. So let's make a new. Let's allow. Plugins. Yeah, that's fine. Import settings. Yeah, I did this for, I think we did it for one of our versions of like we were making one sec. Sorry, we were making a select folder, and then we want to give it Unity docs dark mode. Create a Git repository. Yeah, we'll do that. Okay, there we go. Okay. So now what we need to do is we need to create our manifest.json file. New file, manifest.json. Then we copy this. And then we come up here for this. Unity docs dark mode. Description gives you a dark mode for the Unity docs. Manifest version 3. And then we have our little things that we can pop into there. It would just be CSS override or something. Yeah, pretty much. So we just come down here and we're gonna create exactly what they have just to make this easier, because well we need it to do something. We need to verify that we actually have something, right? What was the file name? Hello.html. Right, so we drop that in there. We add. Oops. We don't need Node. Do we need an index.js? No, we do not. We can get rid of that. Delete. Delete anyways. We don't need a packages because we're not using anything. There we go. Beautiful. Okay, so we really only have these. And then does this need anything else? There's the default icon, a hello extension. I don't know if that's entirely something that they just give you, but whatever. And then we come down to here and we want to load, I think it's load unpacked. And then we come to our local project, projects, Unity dark mode, select folder. Or could not do, oh, right, we need that one file. The hello extension one. Where are we getting that from? There's the hello extension. Download raw file. move it, right? Yes. There we go. Here we go. And then we come back into here and when we say retry, there we go. Unity Darks, dark mode. Then Chromium plugin. Change CSS for website. Custom CSS to do. That's not what I want. You only need to complete your manifest to do. If you want to decode programmatically when you insert the CSS, you can use this. It's the easiest way to look through the manifest. CSS. Okay, so content scripts. Here we go. We do this. There we go. And then CSS is going to be Unity dark mode, Unity docs dark mode, CSS. Do we need a content script? I don't think we need this, so we'll just delete that for now. And then we create this file, new file. Where's our CSS? Whatever, Unity docs CSS. Here we go. And then we go to the Unity docs, and it is this one. Go back to our manifest, and we do this and paste. Go. Now, I believe this is going to get loaded in every time that we do anything here. So let's take a look and see what we're dealing with. Lower third here. And if I select, let's change this color right. Let's change the font itself. Let's take a look at this, right? This one here. Computed. There is nothing. There's no style for this. Cool. So let's change the default CSS, change default font color. I can never remember what it is. Oh, it's just color. Okay. All right, let's make the font maybe this color here. Do font family, font size. There we go, font color. Oops. There we go. And then we want the background color. Front end's not really my regular cup of tea here, so just bear with me. I have to look up things. CSS change background color. I haven't done a lot of like really baseline stuff in a long time. Light blue, and I think we want like something like this color right here. Do that. Okay, and then if I reload this, we'll see if it worked. It didn't work. Fuck. Okay, what's going on here? console. Blocked script execution is about blank because the document frame is sandbox and allow. What script is this? Oh, yeah, whatever. I don't really care. Unity's DOM changes. What? Is it actually even loading my file? I don't think it is. I'm not seeing my file in here. Maybe I needed to reload. Let's see. Unity store. Yeah, it's not injecting it. Optimal, the list of CSS files to be injected into the matching pages. These are injected in the order they appear in the array before any DOM is. Oh. Yeah, it's getting overridden, that's why. So it's getting overwritten. CSS. Is it at the end or at the beginning? It's the end. Okay. Reload. There we go. Yeah. Then if I take this. Now we don't want to do that for everything, but we want to do that for like certain parts of it, right? And then here we're just going to see like the sidebar here. So we're going to do this is an ID, right? So we do dot sidebar. And I think that's correct, or is it this? I think it's this actually. So now if I reload and we come back to here, I think it should. No, it's not. Oh wait, no, it's this one. Yeah. Wait. CSS attach to class. Or sorry, ID. I thought ID was pound. It is pound. Maybe I got this wrong. Give me a second. Or I got this wrong. It does say ID sidebar, right? So like you would expect it to work. Here's our ID. Here's our sidebar, right? So our sidebar here, we could do sidebar wrapper, and that's a class. It's a class of sidebar, but it's also an ID of sidebar. We could do this. Let's see if this works. There we go. Then if we come into here, we can see that we have the colors. Let's change the colors. Right? So let's change the color here first, right? So we've got H1. So the H1 has a color here. There's the color of H1. We want that to be lighter. Oops. What is that? It's just H1. Yeah, just H1. Okay. We want this to be a nice light color, right? So if I come here and let's say we take this color here, that's better. Then we can do that and come into here and say H1 color. There we go. I think we still have to reload. There we go. And effectively, we just go through and do this for everything. Let's see this one. Let's see if this one does it. Oh wait, no, this isn't a thing. This one is though. This one's doc still. Yeah, okay. Just need to reload. It's easy. You change your manifest, and then you inject using JavaScript as well. Because we're only doing it for one site, we can do it much easier, right? We don't have to worry as much. But it's effectively like a really complex I say really complex, but it's not, right? Like you're effectively just you're forcibly overriding the colors of things, right? So you can do it for like we can come along here and just be like, we want to do it for all the H1s, H2s, H3s, right? So like the proper way to do this would be H2, H3, H4, 5, H6. Now all of these have a shared color, right? And then you can go through and you can just inject this and it just overrides everything. Right? Not necessarily, because this means that all H1s on the page, no matter what, are going to be this color. Right? It doesn't matter what class they have. Yeah, but when you're doing dark mode for a lot of websites, there's better ways to do it than this, right? This is a good way to do it for like I want everything kind of thing, right? Like yeah, this is for a targeted site. You would do it this way. For like every site out there, you would want to change it. And also if you really pay attention, those dark modes for all websites, they fall apart on some websites because they're not those websites are not structured very well, right? And that's where I can't pay attention. Turning cog. Okay. but yeah, like effectively, like at some point, there's going to be websites that don't meet the right patterns, and because of that, they fall apart. It is what it is. But yeah, it would just effectively be going through this and changing all of this. Right now, I don't want to get I don't want to worry too much about this, so we're just gonna disable this for now. Because it will take me this takes a while, right? It would take me a while. If somebody had one already made for dark mode, then we could just steal that or borrow that and tweak it from there. Unity docs dark mode CSS. Yeah, we get into things like this. Stop right there, criminal scum. No, I refuse. Anyways. This is the other one. This is the one that we want.
Hey everyone, welcome back to AshDev. Today we're starting a tutorial series on creating an arcade-style car controller in Unity. In this first part, we'll delve into the intricacies of suspension
shit.
logic. Stick around till the end for some valuable insights. Let's get started and understand the approach of suspension first. Imagine we're shooting rays from each corner of the car, all pointing downwards. Now, if we apply a force to the car, as a ray makes contact with the ground, it causes the car to bounce off the ground. And when the ray is no longer hitting the ground, the car starts to fall again.
I've been trying to use chaos vehicles, but there is some leftover BS from the physics vehicles I got from the marketplace. Why is nothing easy? Do you want to know what you should use? Turning cog, you should just build that one yourself. Don't use the marketplace stuff. There's no reason to use marketplace physics for vehicles. So there are a couple that are reportedly good. If you really want to use a marketplace asset for the vehicle physics in Unreal, it's not. I wouldn't necessarily suggest it, depending on what you're looking for, right? Unreal Engine Orbit. I would. What is it? Orbital? Yeah, this one. And then it's vehicle. So there's the advanced vehicle system. This one's fairly good. Rtoon vehicle physics is really good, and arcade vehicle system is supposed to be good. There's one more, and I can't remember the name of it. F-Gear. These four are supposed to be the best ones. If you don't, so F-Gear, arcade vehicle system, Rtoon, and advanced vehicle system. If you don't want to use the Unreal version, right? And now you might not want to use the Unreal version for a number of different reasons, and one being that it doesn't play well with networking. So that's completely fine. But if you're not making a networked game, just use the Unreal one. And it made the car float. I tore them all out. I was just using fucking collision meshes. Don't use collision meshes. It will make the car float. You need to use a raycast. But there's just use the default one that's in Unreal. It's not very difficult to use. It's difficult to tune because you need to like actually understand vehicles. But like after you get used to it, it's actually not very difficult to build. I would show you I can show you mine, but I don't know if it would be good because mine's mostly done in. Actually, I think I've got some. I think we might be able to do it. Like because like I don't think all of it is C++. I think most of it is is Blueprint. Like you can do it all in Blueprints, right? Where is it? Truckcoon. So there's a reason why all vehicle systems tend to use ray casting, and the reason is that you don't get weird collision issues. So if I go to the vehicle, one sec, let me get to the vehicle that I have here. Do Truckcoon, blueprints, vehicle, player, Truckcoon. So turning cog, this is effectively what you need. So one, your mesh needs to be rigged. So you need to have a an actual skeletal mesh, and the skeletal mesh has bones. The bones are at the wheels. This is easy to do because Unity has a plugin that will do it for you. Sorry, not Unity. Blender has a plugin that you can use that's free, that will do this for you. So you just push it through that plugin, and the plugin's really easy to use. There. So you've got your rigged vehicle, right? And then you put the wheels at the socket locations, right? And there's this, and so here's a wheel, right? And this is a static mesh component, right? So we just add in that. It's literally just a static mesh, and we just for the location we scroll down and we just what is it? It's under the socket. Socket. Yeah. So parent socket, we just put it on the left, rear left wheel. Okay. And that just lines up to whatever your bone is, right? So rear left, do rear right. There we go. Then, and that's that. And then all we need to do is come down here and we go to the chaos vehicle movement stuff. And then this is where the rest of our settings live. So our wheel setup, right? We can have stuff here, and here's specifically is our wheels. So we have a blueprint for the wheel front and the wheel back, right? Because each one of these is a bit different. And these are overwhelming at first, but you don't have to do all of this. You can do this entirely as you go kind of thing. So don't worry too much, right? So you flag it as whether or not the axle is a rear wheel or a front wheel, right? And then you can put in all of this wonderful, this is all going to be defaulted anyways, so you don't have to configure all of this. This is something you tune with, right? So you just put in this information effectively, or just create a default wheel for the front and the back, right? And then when you come into here, you just select the front wheel and you name the bone. Select the other front wheels, name the bone. Right? Select the back wheel, name the bone, and so on and so forth. Wait, then what was the problem? Was your vehicle too light, maybe? Suspension too powerful? 'Cause it can make it really bouncy. Yeah, like as long as you've done this properly, it should just work. Unless you used, I do not use the vehicle template. The vehicle template is a buggy mess that introduces actual runtime errors into your code base that cannot be removed. Do not use the vehicle template. It will fuck up your project. So you got to start from scratch, like completely from scratch, or like third person. Do the third person project and then add the vehicle there, right? But yeah, no, it's weird. If this system didn't work for you, that's fucked up. There's definitely something greater wrong, right? Because this should just work as long as you've configured this all correctly, which I'm likely you did, right? Like there's so many tutorials online about it. Then it should just work. I can understand it feeling like shit at first though. Oh god, it's so difficult to use. So hard to use. I don't even want to think about how difficult it is to use. This one's pretty easy to use from what I read about. This one's supposed to be easy to use. This one's really difficult to use. And this one's supposed to be easy to use. But this one's supposed to be like the easiest out of all four of them. Where were we? Right, we were watching this guy's AI.
Again, this cycle could keep the car bouncing endlessly, so we need to fine-tune the exact amount of force needed to maintain the car just above the surface, avoiding any unnecessary liftoff. I'll explain how we achieve this later in this video. Now let's start with our project. Create an empty object and name it car. Then add a 3D cube under it. This cube will serve as our temporary car body, which we'll replace with an actual car model later. Change its dimensions so that it can look like a car. Next, create another empty game object and name it ray points. Under this object, add 4 more empty game objects. These will mark the positions from which we'll project the rays. When positioning these, ensure their placement is symmetrical for optimal balance and performance. Also, label them according to their positions. Now, let's dive into the coding part. Begin by creating a script named car controller. In this script, add a header called references. Beneath this, declare a rigid body named car RB to represent the car's rigid body. Then, create an array of transforms named ray points. Each surface titled spring. When it's not being compressed, get the car RB. Let's break down what each of these variables mean. Rest length is the standard length of our theoretical spring when it's not being compressed or stretched. Spring travel is the maximum distance our spring can either compress or extend from its normal position. We will use this to calculate the force to apply based on how much the spring has compressed or extended relative to this maximum travel distance. Spring stiffness represents the maximum force our spring can exert, which occurs when it's fully compressed. Now let's take on the suspension logic. Start by creating a function named suspension. Inside this function, declare a raycast hit variable named hit to hold data from the raycast hit point. Then, introduce another float variable named max length, which represents the maximum length of the spring, calculated as the sum of rest length and spring travel. Next, wrap all these operations in a for each loop, since we need to execute them for each ray.
Rest length plus spring travel. Where's spring travel coming from? Oh wait, what was spring travel? Oh, spring travel is the
compress or extend from its normal position. Spring when it's not being compressed or stretched. Spring travel is the maximum distance our spring can either compress or extend from its normal position. We will use this to calculate the force to apply based on how much the spring has compressed or extended relative to this maximum travel distance. Spring stiffness represents the maximum force our spring can exert, which occurs when it's fully compressed. Now let's take on the suspension logic. Start by creating a function named suspension. Inside this function, declare a raycast hit variable named hit to hold data from the raycast hit point. Then, introduce another float variable named max length, which represents the maximum length of the spring, calculated as the sum of rest length and spring travel. Next, wrap all these operations in a for each loop, since we need to execute them for each ray point. Thus, for each ray point in our ray points array, we'll apply the following logic. Use an if statement to shoot a raycast from the ray point's position in downwards direction. Use out hit to store the ray's hit data. The ray's travel distance should be the max length of the spring plus the wheel radius, ensuring the ray covers the entire length of our suspension components to be able to reach the ground. The raycast will check against the drivable.
The ray position. Interesting.
Layer mask to determine valid surfaces. Now, let's create a float named current spring length to figure out how much the spring has contracted from its resting state. To do this, we'll subtract the wheel radius from the hit distance, which gives us the current length of the ray. When the
okay, and this is coming back with 0, which is the problem. Okay, let's try and get that worked out here. Let's see if we can get fucking keep going to the wrong one here. Close the physics sample for now. Okay, so to draw lines, spring direction, we need the ray distance. This is our ray start and result position. And then if we just want to do the debug.log, ray distance, and we go like this. the start position that we put in here is, yeah, okay. So we're giving it the max length. Yeah. How's the program going? Slow and painful. Okay, so our rest distance is good. Okay, so we've got our distance. The distance is working. Ray distance is working. Okay.
The spring is in its resting position. This calculation will be equal to the rest length, which we're using as the spring's length. Next, introduce another float named spring compression.
Actually, wait. This should be the other way around. Because this should be a negative number. Oh, wait. No, it should start as a negative number and it should end as a non-negative number. Actually, wait. No. It should never be a negative number. Sorry. Give me a second. There we go. But they're suggesting that we do this based off of the... Sorry to hear that. I heard programming is slow and painful. That's why I have never tried it. But this only makes what you do more impressive, I suppose. Are you getting the support you need from the Unity part of our dev community? Yeah, from the Unity dev community, yeah. Or do you mean like on my Discord? I don't think I've actually asked anything in there. Yeah, the Unity Discord's been pretty good so far. Okay, so like let's see here. So we have the ray position, right? And we do minus up, which is down, right? Then we've got our out hit, which is fine. Then we've got the max length plus the wheel radius, and we're looking for drivable. Okay, so we've got that. That's correct, right? The max length is the rest length plus the spring travel. Okay. Yeah, we've effectively got that. And then we do hit distance minus wheel radius. Result position minus wheel data dot radius.
Compression. This variable will hold the current compression of the spring, so we can apply force accurately. It's calculated as the rest length of the spring minus the current spring length, showing how...
Okay, so spring compression. Okay, so I'm gonna get rid of some of this. this one here doesn't work, so we're going to get rid of it. Then all of this doesn't matter, so we're going to get rid of it. Then this doesn't matter, so we're going to get rid of that. And then this we're going to comment out because we just don't, we want to do this a little bit as we go kind of thing. Okay, so we've got the raycast if it hits. And then we've got the spring compression, which is the current spring length. Do we have our current spring length? Rest length, which is there. And then spring travel is the max length. I will need better document. I will need better naming eventually here, very shortly. The current spring length we are calculating, so we could actually update that. To do current. Oh, sorry, no. We have the local transform, right, which is our default location. This is the wheel data dot local transform, rest local transform. And then if we want to calculate the spring compression. There. Let's also do this. Rename spring. There we go. Now what we would do is we'd take the rest location. Let's see. Figure. We'll do this after here. Get the difference between the local transform position and the rest location transform position. There. And then we set this to the vehicle controller, no, vehicle wheel data dot, sorry, no, wheel data dot value dot spring compression equals difference. And then I think this needs to be a ref. There we go. There we go. Now we've got the difference there, but we don't see here. There's our wheel difference. That's fine. That will tell us where the wheel's at. We don't need any of that anymore. Okay, so the ray distance here to do, and then there's our ray distance from the start, which is the yeah. And then we do, he was suggesting the rest length minus the current spring length. So if we do, and this is going to be the spring compression, float spring compression. Spring rest length minus current spring length. Where's current spring length? Oh, wait. Ray distance minus wheel radius. Dot radius. There we go. And then what we want to do is we want to do spring compression. See what we get. Cool. Well, we're definitely compressed.
How far the spring has moved from its rest position. Finally, we divide this by the spring travel to scale the compression ratio between 0 and 1.
The rest, okay, so the max length is the rest length plus the spring travel. Rest length. Okay, so that's the max length. And that was also a float. Spring travel. Which I think is the, yeah, that is the max length. Okay. And then we divide this by the spring travel. Divided by spring... Or sorry, spring travel. What was it? Max length. Ugh. Oh, we're still running? No, not okay. Now let's see what we've got. Okay.
Enabling us to understand the spring's compression in a normalized manner. Create a
give me a second here. I just need to move this over here. Okay, let me make sure I've got this right. Rest length minus current spring length, which the current spring length is this. Wait. This is the hit distance minus wheel radius. So if we do this, this is correct now. So this is the hit distance, right? So let's do that. Float hit distance equals this. And we can do, this is going to be current spring length. And then we can say the hit distance minus the wheel radius. And then the spring compression is the rest length subtracted by the current spring length divided by the
spring travel to scale the compression ratio between 0 and 1.
Spring travel divided by spring travel, which is wheel FL data dot spring travel.
Enabling us to understand the spring's compression in a normalized manner. Create a float to hold the spring force.
Oh, and we need to wrap. We want to wrap this. So this is done before the division. That makes sense. Okay. And we just do that so we can see it better. There we go. Now, if I come back into here, what are we going to see? The trick is that we have to get rid of all rigid body stuff because we can't use rigid body. So we can't get velocity that way. We have to calculate it ourselves. Cool. We're getting a better number.
Calculated by multiplying the spring compression by the spring stiffness. This represents force required based on the spring compression. Next.
Okay. Float spring force equals spring. So this would be wheel FL data dot spring stiffness or spring strength times spring compression. And this is the spring force. Beautiful.
Apply this force to the car in an upward direction at the ray point by using add force at point. This action pushes the car upwards from the contact point, simulating a realistic suspension effect. To visualize our suspension system, we'll draw a ray from the ray point's position to the hit point's position in the downward direction of the ray point, using red color to indicate contact. If the ray...
Okay, so this part we have. So this would be the spring direction, which we have up here. And then we do this times spring force. And then we're going to draw the debug here. Yeah, that's fine. It worked. Look at that. Okay, so now we need to take this entire thing here and we need to put this into into a public static 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 void apply suspension apply suspension force. And then effectively what we're going to do is we're going to take all of this and we're going to move it into it, right? So we're going to take this entire thing here and move this into here. And then we're going to come into here and we're going to that's not what I said to do. Okay. This needs to be moved. So we're going to take that and move that to right there. I think. There we go. Then we're going to take in everything that we need. So we need the suspension world location. And that is, we only need the position, right? So this is going to be a float 3. Yeah. Suspension world position. We need the local up, right, which is also a float 3. The wheel data, we could pass in all of it, but I think that we want to pass in as little as possible. So this is a spring travel is a float. No, we want to pass in the wheel data. Never mind. Vehicle wheel data. And then we do wheel data. And you know what? I think we actually do want to do this here. Yeah. And this is a local. I think this is a local to world, right? Yeah, local to world. And then we need our physics world. Physics world, and this is a there. And then this is a ref. This is also a ref. This is also a ref. I think that's it, right? No, these are just ins, right? We just do in. Because these are... Oh, no, this one needs to be a ref. Yeah. Chassis mass. Are we actually... Oh, that's doing the read-write thing, right? I think this can just be an in. Same with this. This can be an in. There. And then we need the local to world position. And the vehicle can be... And the... Oh, wait, this is just a position. So this we can just say is just a float 3. In float 3, center of mass. Center of mass. Okay. And then what's the issue here? And we take this and we come up to where we're applying it, and we just do this. No, this needs to happen before. Here. Yeah. And we are also going to pass in a ref for a raycast hit, our input. And this is going to be raycast input. There we go. We're going to keep the raycast input out here. I think this is read only. Does this still need the N? What's our center of mass again? This is our center of mass. Oops. Center of mass, it's that. Right, we need the raycast input, which is the third value. We need our physics mass. Where's our mass? Here we go. I did this one as a read write, but I don't know that we actually need it as a read write here. There. This is just the wheel data. And argument. Does this need a ref then? I think this is just an n. Which ones are ins and which ones are refs again? The first three are refs and the rest are ins. Yeah, okay. Let's see if this works. This is either going to work or it's not. What's the issue here? Yeah, okay, that's fine. It worked. There we go. And now we can do this effectively for all of them very easily. Front right wheel data. Do we have that wheel data? We do not. Okay. I will be right back. All right, here we go. Can I use a system component in here? Oh, wait. We should just be doing this. Instead of this, we just do this. And instead of that, we do this. There we go. God damn it. we have to take this into it. Damn. Fuck. Because we need the wheel start and end and whatnot. Fuck. So this needs to go in here, and then we delete the raycast here. We move that over, and then we say wheel data. Go. So now we have it here for the front right wheel or front left wheel. Okay, so we make sure that this still actually works. Because if this works, then it's going to work for all the wheels. Okay, so it works. So now what we can do is we can come into here and we can take this and we can just repeat it, right? And instead of this being the front left wheel, we say the front right wheel and the front right suspension, right? And now we can apply this force to all of them, which is going to be the rear right and rear right. And then we do this here on the rear left and the rear left. Now we have suspension on all of our wheels. So our spring is probably not correctly calibrated here, and that might be the problem. If we go to the suspension and we say the strength of 25. Wait. Yeah, 300. That's probably why. I feel like that might be why. Look at that. I needed something that UE doesn't have yet. There are things that UE doesn't have. Yep. So the mass entity system is still experimental, and it's a buggy mess because of that. And I need it for this game, so. Not easy. You have to do everything from scratch. Yeah, no, it's an actual problem. Yeah, that is kind of the nice thing. Rider was good to me that way. Although if I was using Visual Studio, it would stay the same too. It's still updating. There's a very noticeable delay between these updating, isn't there? Or no, wait, it's not powerful enough. That's what's causing that. Yeah, that's what's causing it. Where's the draw line? Oh, there's my draw line. Get rid of that. So 350 is still not enough. Let's do 600. Oh yeah, that's another development. So I got a Blackmagic ATEM Mini, and I was having problem. Oh wait, no, it was the Blackmagic editor keyboard, and I was having blue screening problems with it due to a driver issue, and the driver was blue screening on Windows 10. So I was like, okay, well maybe Windows 11 has a different driver that's stable. So I tried out Windows 11, and I was just like, by that point, I had done 2 restores in a 30-day period, and I was just like, no, it was 3 restores in a 30-day period, and I was just like, I just do not want to be asked to do this again. So I just stuck with Windows 11. Because at the end of the day, I'd have to do it again in October anyway, so it's just like, fuck it at this point. Gotta say, I'm not a big fan of Windows 11 so far. Okay, so we got the force being applied, but I don't think this is the correct thing. I don't think it's an impulse that I want. I think apply. Is it maybe it's linear? For many reasons. We could try this as just like, we could do both of these. No, I don't want to do that. Let's see what happens if we crank up the suspension to, let's say, 1,000. New keyboard. At least it's not blue screening. Yeah, there's our suspension. 1,000 really makes this rock. Yeah, it's pretty insane. I feel like we need to do a linear, like just a, eh, we need to apply some angular here as a whole. Let's just add a little bit of linear support here. And then that should give us like at least a little bit of a hover, I think. I'm just going to do this for now. Let's see if we can get a hover out of the linear force. And then what we'll do is we're going to figure this one out in a second here because Okay, so I think I know the problem. It's these. These are definitely the problem, I think. So we need to performance optimize for that. Unity dots bring data from other from other entities into on update. So it's the system. Like it's that using the system API is probably what's causing the problem. Interesting. Yeah, because this no, they do use it here. CE position. So I think what we need to do is do a for loop through these, right? So if we do this here, and then we grab these all at the same time, right? So we do a wheel, a vehicle wheel data list, right? We should be able to do this, right? This is C#. Mm. And then the other one is this. That was weird. Okay, there. Then what we want to do is we want to do for int I equals 0. And we can minimize this like so. And now each one of those is going to do the thing. But now I think we can bring that out of a for loop, or we can bring that out of here and get a little bit of performance back. But let's see if this actually increases the performance, because I have a feeling that, like, because we're applying it separately like that over time, that maybe there's a disconnect between like the application and whatnot. So okay. So this is a native array. Let's see if this fixes the problem, or at least some of the problem. Hey, bro. MGF. Hey, welcome. I think we're falling too fast. Either that or this is taking too long to execute. I think also we want to do this. I think we've got this, but I'm going to double check. We do not. So we do this, this. Prepare vehicle jobs. Okay. We can just skip this. That's going to be this is going to be important for wheel update position. Then we do the command buffer. We don't need this anymore. So we can delete that. We don't need the local transform, so we're going to get rid of that. The command buffer, we're going to go down to the very bottom here. Oh, this is just for the wheel. So we don't care about that right now. Okay, so we don't care about this. So I'm kind of like on the fence. I'm not sure if this is like an issue with the code being slow, or if it's an issue with it not being strong enough. You make video game? I'm making a video game, yes. I think it's not being strong enough, or it almost feels like it's not applying correctly. Because apply here, apply an impulse to a rigid body at a point in world space. We're doing that, right? Let's do 5,000. Let's see what 5,000 looks like. Oh, that's interesting. So something else is happening. Something else is definitely happening. And I think it's being pushed down at some point. Yeah, I think the higher I get, the more I think something's causing it to be applied in the wrong direction. Because you would expect that like 5,000, it would just go up higher, right? Well, 5,000, it doesn't go up higher. It actually goes down lower. What if I do 50? I don't think this is right, but like what if 50? What happens then? Like is it a lower number that I need or a higher number? So it's definitely not 50. What if it's let's go back to 300. I think 300 was one of the numbers we tested, right? Three hundred's not quite enough. $600? $2,000. See, it looks like something's causing it to go down, up and down. Okay, let's take a look at our math here. Spring direction is local up. So it should always be going up. It should never be coming down, right? Let's take a look at this impulse. Debug.log. Yeah, there we go. That's a downward force, not an upwards force. Or wait, no, wait. This is the wrong direction. Right? No, this is the right direction. This is the wrong direction. So something's giving us a downwards force. There's our negative force right there. Spring force can be negative. So what we want is math.abs. So let's do 300 now. 600. $700 maybe. Oh, that's interesting. I want. Hmm. I need to figure out how to smooth this out. What happens if I change this all to like 1,000 now? Unity, figure out how much strength my springs need. Actually, it could be the dampening that's the problem. Come to think of it, yeah, it could be the dampening. Let's give it a dampening of like 500. And we'll bring this back down. We'll say 800. Okay, that's a bit better. What if this is 1,000? These numbers feel way too big. I feel like we need a little bit of a linear force just applied to the entirety of the base here. like what if we just need a hover force here, right? Like what if we take this and instead of doing this like this, we do static void apply apply base force. Would that work? Okay, what if we just do this for now? I'm just gonna do this for now, real quick here. Just bam. Just for now. So bear with me. I'm gonna have to break this out and do some real quick stuff on this. But the idea is that we apply effectively like, hey, if we're gonna do a ray from the center of mass down, and if we hit anything, then we'll apply a constant force. Is that yeah, apply a linear force. Mm. Let's see here. Figure out force to make object float. To make an object float in place. Float in place. Where F is the buoyancy force. How to float an object in Unity, make object float in place.
Hey, welcome back. Today we're going to be going over how to make an object float in Unity using the animation tab. So let's get started. So here we just opened up the project. I'm using Unity 2020, but this can apply to any version. So once you are in your project, first thing first is we need an object to animate. So there are two ways to do it. You could do it via code and you could do it via an animation. Today we are going over how to do it via an animation. So we're going to go create an object. We're going to start off by creating an empty game object. We're just going to call this flying object. Once we have this in, we're going to position it up a little bit so it's floating. We're going to right click on flying object, go to 3D object, go to cube. We're going to shrink this down a little bit. And the most important thing you want to know is, first of all, cube has to be the child of flying object. And on top of that, the cube has to be zeroed out. Otherwise, this will not work. So now that we have this set up, we're going to go to our window, go down to animation, and go to the animation tab right here. I like to drag mine down here just for ease of use. So let's go ahead and click on the cube. We're going to create a new animation. I'm just going to call this floating cube animation. You know what? The answer might just be to steal the Raycast car from the physics demo. I'll be right back.
Okay. So, since it's not working, it's not working. Constance. We're going to steal this. I say steal this, but it's like it's Unity test scripts. We're just I think we're gonna fold here. I'm disappointed. I can't get them to smooth out, and I don't know why. But you know what I can do? Move on to something else. I've spent entirely too much time on this, and what we need is we need to move on. Don't save. Okay, let's duplicate this. Let's just duplicate. There we go. Okay, there we go. And then we're going to go to the 4x4 here. Okay, we're getting rid of this. Remove component. We're getting rid of this. Oh, wait. That was not what we wanted to do. This one. Where's this coming from? That box. Okay, so we get rid of this. Remove component. We get rid of this. Remove component. Rid of the chassis. We're actually just going to remove this. Remove component. And we'll add it back. Collision box. There we go. Actually, you know what? We'll do this. I still actually would like to keep this. But I wonder if this is what's causing the problem. If it's too complex, maybe. Okay, so we come to here. We remove this. We add in a vehicle. We add in our dots vehicle authoring script, blah, 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 right? click here and then we do the vehicle authoring. What? What do you mean you cannot use unsafe in this context? It's literally working right here. Works here, doesn't work in mine. I shouldn't have to change this, right? Oh, this is the change vehicle thing. The unsafeness one in this one actually bothers me because, like, I don't know why that matters. This is a settings. This has to be a settings thing. It's the only thing that makes sense. Could not be found. Are you missing? Do I have not. I don't think I have entity graphics, do I? No, I have that. I have the input system. Mono. You got that. The switcher, serialization, geographs. I have the test framework. These are largely the same. I'm looking for why this doesn't work. So I brought these over from this project and they do not work. Like the code is actually broken. It compiles just fine here, right? Like this is going to build. There's no errors. Same, exactly the same code, literally line for line. Actual errors. Specifically, one of them here is in, I think it was, yeah, here. Like this here is saying that this can't be used in this unsafe can't be unsafe constructs in the safe context. But like this exact line of code works in this project. What the fuck, Unity? What the fuck? There is a bunch of common ones that we'll probably need to bring in. So we'll do this and we'll do add. We'll come over to here. I'm gonna do this. Projects. Create folder common. Like it shouldn't be because we should be on the same versions, right? Actually, yeah, it could be. I wonder. First is the same version. Collections is a different version. Entity graphics and entity, I think, is a different version too. Yeah. Okay, so if I just do this, let's just do this. We're just going to do this. We're just going to delete this. Yes, delete. Fine. Whatever. And then we're just going to go in and we're going to literally just fix everything. Because I think that it's not that bad to fix. I don't actually want your camera stuff. This physics body baking system is bothering me. And this is in the vehicle mechanics. 128. Oh, this is an import. Potentially. Wait a second. Unity 3.5. Samples. Oops. What is this? This is next to common. Okay, so if I do this, we do that, and then we take this samples. Yeah, samples. You just bring this samples over. This should fix some of my problems. At least one of them. There we go. The unsafe one, I don't have a fix for this, but This is fine because we don't actually care about this. Right, we don't need the Forbic at all because we're not doing that. Oops. We're going to do that, and then we're going to come back into here. We don't need Forbic. Okay, there we go. And then we do this. The active vehicle. Give me one moment here. And come over to here, and we're going to bring over the active vehicle system. And then we're going to edit it. And when I say we're going to edit it, we're going to straight up just yeet the shit out of it. Because this I think has requirements that we don't have. Right? No, that was all we needed. Huh. Okay, we got it working. Okay, so this is the vehicle authoring. Comes into here. Our top speed, we'll say 20 and 35. Leave the rest of this normal for now. Target camera is main camera proxy. We'll deal with the camera system later. I don't really care about that too much. Then we need a vehicle mechanics. We'll say 8,500. Wheelbase. And we can say whatever for that, doesn't matter. This is our wheels, right? So then when you're going to come down here. Nothing. Okay, so then our wheels themselves have nothing on them. Remove component. Remove component. Remove component. Remove component. I see what's going on here. Graphic left. There we go. Suspension has nothing on it, so we can get rid of our suspension stuff. We have a physics shape, which takes up everything, and then a chassis. Ah, okay. So our chassis doesn't have a physics or a box collider. Move component. And then we have a I'm gonna get rid of that. And then we do create an empty here, and then this would be physics shapes. There. Bring that up. And then the physics shapes has a bunch of just physics shapes, right? So then we create an empty, and this will be the cab. And then this can be a box collider. And we duplicate this, and we're going to call this one box. Look at that. Huh? No. I haven't touched the camera sheet speed. I don't think I've been moving much. It's not there's no problems on the OBS side right now. Okay, then we do the 4 wheels, which are going to be let's do this real quick here. Just going to add our wheels back here. Beautiful, 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 beautiful. Okay. Which one of these wheels, like where? Okay, so it's the suspension that has it. Okay, so the suspension has it. That's fine. Okay, so the wheels themselves don't have any offs other than like a rotation. Okay, so we're fine. Oh, wait. Interesting. Oh. Oh, neat. Okay. Whatever. I don't. We're just gonna leave the wheels where they are. Okay. So and they're grabbing the wheel BR. So it's this one. Then we have steering and drive wheels. That's weird. We're missing data. So we've got that, but we're wait. Are we? Okay, no, we're not. Max steering. Oh, okay, I was looking at the wrong one. It's this one up here. Okay, so then we go to game. So not that. We go to scene. Take a look at this one. Which one is this? This is the old one. So let's save, and then we're going to delete this. Then we're going to take our new truck. Put that in there. Take a look at this and zero this out. And then bring this up. And save and hit enter. Hit play and see what happens. 10 out of 10. It fell through the world. To hell we go. Yep, pretty much. I wonder if it wants this environment to be part of this actual scene here. Like, I wonder if that's a thing. Oh, okay. This is not supposed to be a box collider. It's supposed to be a physics shape. That's surprisingly good. Component, physics shape. Remove component. Save. Save. Play. Hey, it worked. And then they're suggesting just default for now. So we definitely have a problem where we're not getting so like here we can see interesting. Our wheels don't move, but our vehicle does. Our vehicle actually doesn't feel terrible. So this is what we're supposed to have, but we don't because we're falling through the world. Oh, the world needs a physics shape. Wow. Okay. Walls need a physics shape. The ground needs a physics shape. We can remove this though. There we go. This object will consider static. This object will be considered static, and a physics body authoring component if if you will move it at runtime, target will be unparented during the conversion process in order to take part in physics simulations. Interesting. Interesting. There's a lot of setup that I didn't know about. Sure. There we go. Okay. It's because there's an error. There's an error on TruckCoon. Camera to transform. Please don't error. God damn it. It's gonna error. It errored. What's the error here? Camera smooth tracking settings. God damn it. Give me a second here. There's a okay. Is there a way to take this entire project here and use it effectively to make my project and just rename it? I'll be right back. All right, give me a second here. Oh, okay. I have a couple ideas. So bear with me here. What I'm going to do is I'm going to delete this. I don't want that. Don't want it at all. Sweet. Save. Console. Hit play. Get singleton vehicle input. So it's part of the change vehicle system. Nothing's actually using the change vehicle system, I don't think. Not directly, at least. I don't actually want a change vehicle system, is the other thing. Because we're not going to be using that, right? We come back to here and we delete the change vehicle system. Okay. Vehicle input handling system. I'm trying to avoid that because they've got a bunch of stuff that I don't want. Give me a sec here. There we go. Wait, what if I do this? Default volume. Is this the... I feel like... Is this the... Oh, I don't even know. Fuck it. So here's what I'm thinking. We do this effectively, and then we create a new... Okay, so here's what I'm thinking. Just bear with me here. This is our project in question, right? The one that we want to replicate. So if... I think that was it, right? Yeah, okay. Okay, so if I take this physics sample and move it over here, and we rename this, just do this. Unity Truckun. This should have everything we need, and then we can just delete the things we don't need, right? And then we'll have a vehicle. We'll finally have a vehicle. Then here we're going to say create folder Truckun. And here we're going to do a create folder, and we're going to say Unity samples. Actually, you know what? We'll leave that stuff there. Okay, so now we have this, right? We can select this, even though we don't actually care about selecting the vehicle. The camera's terrible. Let's just put that out there. The camera is god awful. But the vehicle works. It does need a little bit of work, but it is working. Yeah, so we want all of this gone. Delete. God. It moved it. God damn. Fucking hell, you've got to be kidding me. Git restore. That's exactly what I just did. Git undo all changes. Yeah, whatever. Actually, wait. Doesn't this just go into the... Yeah, whatever. I'll just move them back. Usually I do the whole like right click moving because it gives you the option to select one. And then I can just be like, I'd like to actually just move this. And then it moves it.
Set up to work.
Okay, there we go. We got it back. Now we can move all of those things back there to fix the problem. Oh, it's the character controller. This is the one that it's wait, no. Stateful collision event. Interesting that it's saying that. I kind of wonder which one it is. Whatever, we'll just move all of them back. Ooh, there we go. It's not actually what I want, but it's fine. One sec. Got a message from a friend. Biasing refers to the method of called a int to binary, allowing for both positive and negative values to be represented within a limited bit range. Where the exponent is biased to simplify calculations. Number 5 would be represented as 133. Number 5 would be oh, wait, yeah. Yay! It's actually a really good explanation. Okay, we've got our vehicle. Let's convert this vehicle to a to Truckcoon now. I almost wonder if I can do this. Unity samples. Can we take all of this and put this into Unity samples, and will it still work? I feel like the answer is yes, but you know, you never know. Be right back. Dad's here. All right, have a good one. We'll see you in a bit. Wow, they're stuttering already. Yeah, there's a lot of stuttering. Nope. All right, so that's not the option. Unity dots vehicle.
Hello everyone. In this video, we are going to explore one of many ways to have player drive a car and also tow along some heavy payload over a set of obstacles or humps. We are going to use Unity's new ECS and hybrid fashion to achieve this behavior. Let's get started. We are going to have 4 different C# classes. The drive bridge is going to interact with wheel colliders by applying brake, steering, and motor torque so our rigid body can move. And Unity drivers. I also call them pretty stable. We also want wheel mesh to assign our drive bridge to driver component.
Okay, so when was the last time this was updated? 5 years ago, 2 years ago. We're not going to bother with that. Unity dots vehicle system.
Hello, everybody, and welcome to episode 22 of the Hot Pass. Hello, everybody, and welcome.
The amount of dots stuff in is kind of depressing. Then like it doesn't exist. There's so little going on in the world of dots right now. I know it's because it's like it's still new, but still. Oh well. Well, we tried. Unity, smooth out impulse. I know this is very old, but in case anyone's is an instance and not smooth at all. Using force, using the force mode force would be more significant if you want realistic moving objects. To get rid of the jerk when actually, you know what? I wonder if I do this by, give me a second here, to here. We come back into the what if I add in the, instead of just doing this for the impulse, what if we give it delta time divided by delta time? Or no, times by delta time? What if we do that? Because we want to apply a constant force, so maybe delta time will give us a smoother reaction. Smooth out, wait, Unity, smooth out instantly firing impulse. C# ref and in. Ref is used to state that the parameter passed may be modified by the method. In is used to state that the parameter passed cannot be modified by the method. Out is used. Okay. But I think it still passes the reference, right? I'm making a game that is called Isekai Crusader Truck-kun's Realm Rescue. So you play as the truck and you run people over. But right now, our truck is doing this. Oh, wait, one sec. Not applying the force to anything. Right now, our truck is doing this. Yeah, the complete opposite of what we want. we wanna smooth it out. But we have very limited we tried the linear velocity. But that doesn't work. I want to say angular maybe, but like I don't know. I'll be right back. I'm gonna go grab food. I'm pretty much back to. I need water. Okay, I'm back. So, okay, if I draw the debug, right? Oh, I scrapped it. Scrapped it all together. I just decided to go back. Wait a second. Wait. You think it's dampening? No, but I'm not sure why we would need a physics material. You know what I just thought about? You think it's because the wheels are always at maximum? I just thought about that. Well, the vehicle itself is not bouncing. I just thought about this. What if I do this? This is a local transform for the wheel, which is under wheel data. No, it's not. Fuck. Give me a second. Okay, one sec. Wait, check this out. Check this out. Check this out. Okay, so if I go back to the game, let's take a look at this, right? And then we go into here. Let's actually start rendering out the wheels because I think this might actually be the problem. I didn't even think about that until just now, that this might be the problem. The wheels aren't actually moving. We never update it. So every frame we update the wheels to be at the max possible distance down. But that's not actually what we want. What we want is this. Right? So what if we do that? You don't want colliders on your wheels. There's too much funkiness when you have wheels attached to, like, actual physical wheels attached. Wheels are usually there just for show. I think the solution is to move this up. Into here. Which means that we have to update this a little bit more. Okay, so mm. Hmm. Yeah, so we never update the wheel. So we need an out. Because effectively all we need is we just need this new position, which is just a float 3. So we just need an out float 3. Hmm. We have wheel data, but we don't have the local transform for the wheel. Uh, Hmm. Calculate the new spring length. Yeah, totally. There we go. Spring compression. And we come up to here. And then we do update the spring length on the wheel data. Oh, God damn it. Wow. It did completely the wrong thing. Ten out of 10. Hmm. Right, rear right. Rear right, rear left. There we go. We have to hold. Cannot modify struct. So this would be wheel data. Or sorry, vehicle wheel data. Still needs work. What's up? Okay, yeah, there. What's the error down here? Oh, I think this should put the wheels in the right spot. I wonder if we can figure out what's going on. Where the fuck did it end up going? Okay, so if we go back to main camera. It would feel terrible to drive. I'm kind of curious as to whether or not this would work. That is actually better. Look at that. I can tell you why that's happening now. We don't have the dampening. Dampening is not being used.
Isn't hitting anything, then we'll draw a ray from the ray point's position, extending down to the maximum length, plus the wheel radius, and we'll use green color for this. Lastly, ensure to call this suspension function within fixed update. Let's Walk through an example to illustrate how this works. Suppose the spring stiffness is 100, rest length is 1 meter, spring travel is 0.5 meters, and the wheel radius is 0.33 meters, making the maximum ray length 1.33 meters. Imagine something 0.25 meters high gets under the tire, so the ray now hits this object. Now the ray length becomes 1.08 meters. According to our formula, the current spring length is the ray's length minus the wheel radius, resulting in 0.75 meters. Next, we calculate the current spring compression as the rest length of the spring minus the current spring length, equaling 0.25 meters. Dividing this by the maximum spring travel of 0.5 meters gives us 0.5, indicating the spring is halfway compressed. Therefore, the spring force, calculated as spring compression multiplied by spring stiffness, equals 50, meaning 50% of the total spring force will be applied to the car body. Now, let's move to the editor and see our car's suspension in action. First, we'll set the variables, attach a rigid body to the car, and set its mass to around 1,000 kilograms to mimic real-world values. And then create a layer, drivable, and apply it to the ground plane. And in car controller, set the drivable layer mask to drivable. Then set spring stiffness to 30,000, rest length to 1, spring travel to 0.5, and lastly, wheel radius to 0.33. Now, if we play the game, the car is bouncing endlessly. To eliminate this issue, we will introduce a concept known as damping. In real world, a damper is essentially fluid within in the suspension system that limits its movement. When the spring attempts to move, the presence of the viscous fluid restricts its movement, allowing the spring to return to its resting position more swiftly. However, the viscosity or density of the damper fluid must be precisely chosen. There's a specific formula to determine the ideal damper stiffness. For optimal suspension performance, zeta's value should fall between 0.2 to 1. Now, to incorporate damping into our car controller, we'll create a float named damper stiffness. You can think of this as representing the density of the damper fluid. Now, within the suspension function, introduce a float named spring velocity. This variable will capture the spring's speed, enabling us to calculate the necessary damping force. Just like real-life dampers restrict the movement of a spring, we apply a damping force based on the spring's velocity to counteract its motion. Spring velocity is determined by the car's velocity at that point in the upward direction, as the spring is attached to the car and moves with it. We are using the dot product to calculate this because it provides velocity in a specific axis, and we need the spring's velocity in the upward direction. Next,
get point velocity. Fuck. They want us to use that point velocity again. That might be it. We'll try this. We're just gonna hope that this actually gives us the right thing. Wait. Vector. No, it's rigid body dot get point velocity. Okay, there we go. That's a world point. The velocity of a rigid body at a point in world. I want to say that it's just velocity, right? Or linear. We'll just say that it's this. And then we do the okay, so that we got that.
create a float named damp force. This will be calculated as the spring velocity multiplied by the damper stiffness. The higher the spring velocity, the greater the damp force required to counteract and slow down the spring's motion. Then, introduce another float called net force. This represents the total force to be applied to the car after incorporating damping, and is simply the spring force minus the damp force. This is because a higher spring force, which contributes to greater spring velocity, requires adjustment. Now use this net.
One sec.
Net force in place of the original spring force to apply to the car.
I believe these have like it's on the wheels, right? No, it's not. It's on the suspension. Dampening.
Car. In the editor, we'll set the damping stiffness using the formula. To calculate the damper stiffness, we'll adjust the formula by moving the denominator to the other side, along with zeta. Starting with the minimum zeta value of 0.2, we obtain a value of 2190, and for the maximum zeta value of 1, we get a damper stiffness of 10954. This gives us a range.
Okay, calculator. K is the spring stiffness. What's our spring stiffness right now? I think it's on the wheel, right? Oh, it's the strength. Yeah, that's what it was. $800 times 5,800.
Range within which we can experiment with different values to find the desired damper stiffness. Remember, the lower the damper stiffness, the more bouncy the car will be. I am setting damper stiffness to 3000. Now, as you can see, our car's suspension system is performing.
Yeah, whatever. That's fine. 3,000. That's fine. Let's hit play and see what happens. It's almost there. No, it's definitely not that. Vehicle configuration. Spring compression. Spring wrestling flames, current spring. Okay, let's put our dampening at 10,000 and try that. Try to ignore the wheels right now. And just ignore the wheels. I'm trying. Is it working? Is it working? Let's do this. One sec. What was it? It was
In the editor, we'll set the damping stiffness using the formula. To calculate the damper stiffness, we'll adjust the formula by moving the denominator to the other side along with zeta, starting with the minimum zeta to apply to the car. In the editor, we'll set the damping stiffness using the formula. To calculate
damping coefficient. Suspension mass. So our strength is 800. Our suspension mass is I have no idea how to use this calculator. Yeah, okay, whatever. Enter the mass. 8,500. Never mind. Let's. Can I get it to just not be bouncy, please? That'd be great. Strength. We're making progress. Holy shit, I did it. Wait, is this the good one? Okay. There's our rest length. Oh yeah, 0.06. Rest length of 0.03. Max length of 0.6. Let's just take a look at this. 0.3. I think I'm doing the rest length a little wrong. 0.16. Zero 0.1. I found the problem. I found the problem. See what happens when we go really big. So I got bad math. That's definitely the thing. That the math is horribly wrong. We got it to bottom out at least. 0. Rest length of 0.3. Oh, for fuck's sakes. You can. Okay, so we want the front left. The strength doesn't do anything really here. We'll try that. 4.14 point. Yeah, okay. Was it 0.41? We'll find out in a second. Actually, I wonder if it's a radius thing that we need to increase. I feel like that actually might be it right now. So it's not that. As much fun as that wasn't it. Ugh. Yeah. All right, so we're definitely getting somewhere. I think that the linear velocity thing is probably causing a bit of a problem. But that's just a hunch. Hmm. What is it? It's been the first 2 weeks, right? Yeah, effectively. Yeah, first 2 weeks. First 2 weeks of learning Unity and dots, and I made a jumping car. AshDev actually has a really good tutorial so far, so I think I'm going to keep with that one. Ugh.
Update. Let's walk through an example to illustrate how this works. Suppose the spring stiffness is 100, rest length is 1 meter, spring travel is 0.5 meters, and the wheel radius is 0.33 meters, making the maximum ray length 1.33 meters. Imagine something 0.25 meters.
Make rat max. Oh.
Let's walk through an example to illustrate how this works. Suppose the spring stiffness is 100, rest length is 1 meter, spring travel is 0.5 meters, and the wheel radius is 0.33 meters, making the maximum ray length 1.33 meters. Imagine something 0.25 meters high gets under the tire, so the ray now hits this object. Now the ray length becomes 1.08 meters. According to our formula, the current...
I had my... I misunderstood the numbers.
Spring length is the ray's length minus the wheel radius, resulting in 0.75 meters. Next, we calculate the current spring compression as the rest length of the spring minus the current spring length, equaling 0.25 meters. Dividing this by the maximum spring travel of 0.5 meters gives us 0.5, indicating the spring is halfway compressed. Therefore, the spring force, calculated as spring compression multiplied by spring stiffness, equals 50, meaning 50% of the total spring force will be applied to the car body. Now, let's move to the editor and see our car's suspension in action. First, we'll set the variables, attach a rigid body to the car, and set its mass to around 1,000 kilograms to mimic real-world values. And then create a layer, drivable, and apply it to the ground plane. And in car controller, set the drivable layer mask to drivable. Then set spring stiffness to 30,000, rest length to 1, spring travel to 0.5, and lastly, wheel radius to 0.33. Now, if we play the game, the car is bouncing endlessly. To eliminate this issue, we will introduce a concept known as damping. In real world, a damper is essentially fluid within the suspension system that limits its movement. When the spring attempts to move, the presence of the viscous fluid restricts its movement, There's a specific formula to determine the ideal. In the editor, we'll set the damping stiffness using of 1, the more bouncy the car will be. That concludes this episode. If you found this video helpful, consider giving it a thumbs up and subscribing to our channel. By doing so, you'll stay updated with our latest content.
Okay. I have to rethink some of my values. Also, I want to move some of the data. I wonder if I can move some of the data around. Okay, so we're gonna, because this is gonna require like a lot of extra work to get this working properly, like a lot. I'm gonna put this off until tomorrow because I have to think about it, and I don't want to right now because I'm a little bit burnt out. So we're gonna call it a night. Let's go raid my buddy Don. All right, I'm gonna do some video editing and whatnot. So I will catch you all later. Ta-ta, and thanks for all the fish. You too.